drains well,
But even
but
though
there's a challenge in retrofitting in an existing house to get something to do that.
WSE has done some of those systems, but even theirs, they have everything sloped back and they were still having ice buildup. And they cut the line to see the ice buildup, and it built up in crescent moons, suggesting that it froze gradually over time, and they weren't sure where this moisture was coming from to build up. It would drain back properly initially, but then build up ice and block the lines. So it's a really elegant idea, because then you can get rid of the glycol and you can get rid of heat exchangers potentially.
Yeah.
But the
But a friend
expense
in
of it was
Ottawa, he
bad.
said that he's got some drain back systems, but he actually put some antifreeze into it as.
Yeah, I've heard of that, and I've heard of people running heat tape along the lines, and when it gets
Yeah.
cold, heating the lines too. So this is our basic install for domestic water heating, like would come out of your tap. So we have on this system, which is Enerworks as a manufacturer, there's from 1 to 4 of these panels. On the picture I showed of my house, there was 1. On this house, there are 3. Glycol lines run to what's called an energy pack, which is basically a pump, heat exchanger, and controller. There's a couple other components in there. So when the solar collector has a temperature sensor in it, when it's hotter in the solar collector than at the bottom of this tank, the pump runs. And what that does is bring heat from the solar collector through this heat exchanger and back up to the heat exchanger, back up to the collector. On the other side of the heat exchanger, cold water enters the bottom. It's heated by the glycol flowing through the heat exchanger, and this heated water then rises up into the top of the tank. So a thermal siphon loop is established in the tank as long as the temperature in the heat exchanger is hotter than the water coming into the bottom of the heat exchanger. And it seems to work really well. We haven't had any problems. And one gotcha is we use a regular electric water heater as our storage tank, and the manufacturers are trying to prevent thermal siphoning from happening in your house, because they don't want hot water to flow up through your pipes when you're not consuming it and just be lost through your pipes. So they put anti-siphon devices inside the water heaters, depending on the manufacturer. We have to fish those out so that we have a clear pipe into the top of the water tank. Then
Typically, what size of pump is most commonly used? Like how many watts?
So this system and the thermodynamic system both use positive displacement pumps. And I don't know the rating of our pump, but it measures out to about 23 watts. I think it might be rated as a 30-watt pump. And so I've calculated that works out to about $5 a year in electricity to run that pump. So this tank on the right, the tank on the left is the homeowner's existing hot water tank. So cold water used to come into this tank, get heated through some means, electric or natural gas, and then go out to their taps. We put in what we call an isolation set, and so we divert the cold water into the bottom of this tank, and then when you turn on a tap, so you take hot water out of this tank, it flows through the solar storage tank in where the cold water used to come in. Then depending how effective this has been, a lot of times in the summer the water temperature in this tank is much higher than the temperature here, so that water will just flow through. If you have prolonged cloudy periods or snow covering your collector, or for whatever reason the water in this tank isn't as hot as here, this preheated water will flow in and the existing water heater will top up. So some of the challenges on the Verico home. The first one was, originally we talked about putting 4 collectors on this home, and there weren't going to be any windows over here. So we're just going to put 4 collectors side by side, which is the way the manufacturer intends them to be mounted. But then Ron wanted to put windows in, so we didn't have room for 4 collectors. We used 3, and we put spacing between them. So one problem is 3 collectors are difficult to mount so that you get equal flow to all collectors. Same as if you have 3 storage tanks, it's difficult to plumb to get the exact same flow through them. The space between the collectors causes us to bring our pipes into the wall, into the crawl space, over to the next collector and back out. Whereas if the collectors were abutted, the hot fluid can literally flow 3 inches from one collector into the other. And instead of that, now we're flowing, you know, maybe we have 20 feet of pipe to connect them up. One problem with this home was the heat emitters may have been overlooked in the initial design. Certainly from our point of view, the original spec we thought was to provide heated water to the home and that it would have some sort of radiant heating system. We assumed the in-floor system, and then it turns out that they intended baseboard heating, and the one that they had, well, I'll talk more about emitters a little bit later on. The modeled heat output from the solar system seems to be the original model based on 4 collectors. And I'm not sure they used the same collectors in their modeling that we used in our installation, so I'm worried that the performance numbers that we're able to deliver will be less than what's been modeled. And I'm worried that's going to make us, both the installers in the home and the industry, look a little bit bad when something is sort of overpromised and then underperforms. And that seemed to be a theme on Kelly Winder's talk when he's talking about the SRC monitored systems, that some of the solar thermal was underperforming the expectations. So I'm a little bit sensitive to it. The shading from the deck rail will cause shadows. Even the sun that shines through the glass of the deck, the glass around the railing will reflect energy and block energy that would otherwise have made it to the collector. And then my personal opinion is that some of the WSE branding, the stickers have been placed on some of the solar and in some of the material. It says that they've installed the solar thermal and solar electric systems on this house. I find it might be confusing or misleading for the public as to exactly what systems are here, what's functioning, and who put them in. The Enerworks system that we put in is a Canadian-made system, and it's a little bit rare. When we first started installing the systems, it was the only one where the entire system is CSA approved, as opposed to having a bunch of discrete parts that are CSA approved and connecting them together. The entire system connected together in the same way that this house is a prefabricated house. This whole house has been CSA approved and has a CSA certification. An installed Enerworks thermal water system is a CSA approved and certified system. It has fairly low electrical consumption, you're asking about. The lines, the copper lines running from the collectors are small, soft copper, which makes them easy to route and easy to insulate and cost effective. On the negative side, it has a reduced flow rate, so some of the energy flows may be slowed compared to some of the competitive systems. It's a proven technology for Canadian climates, and I brought an example of why that's important compared to some Chinese-made products. And because of CSA approval, as well as some other factors, it qualifies for every grant that we've known of in Canada that this system has qualified for without any issues or problems. It's becoming less of an issue as the grants are going away, but hopefully they'll come back. So I was going to talk about the different components of the Enerworks system, starting with the collectors. This is a picture exactly the same as the ones on the outside of the house. It's really hard to see in this picture, but there's a little copper line that comes out the top of the collector here, and a matching one on the bottom. That's how the fluid comes in. Then there's some horizontal lines. I don't know if you can see them from where you are, which is where the copper tube zigzags back and forth across the collector. So I've drawn this to try and explain the components inside the collector. So the front layer, which is hard to see, is a layer of low iron tempered glass, which is very clear and very strong. Then there's a bit of an air gap. And then what I've drawn in dark blue is this selective coating that you see here. It's a large sheet of aluminum. It's pretty well a 4x8 sheet. That's about the size of the collectors. And then welded to the back of this aluminum is that pipe that zigzags back and forth, and it's a pure copper pipe. Then on our collectors, there's an air gap. They're open at the bottom. It's about 4 inches.